Hello everyone and welcome to Tableau. Today we're going to be spending time in Tableau Desktop discussing how one can build out a horizon chart using the data that I'm providing here. We're going to be looking at unemployment data by state for about the past 40 years or so. For those of you that have never seen a horizon chart, it's a very powerful visualization type insofar as showing a large amount of information in a very small amount of space. So for example, here what we're looking at is difference from average of unemployment rates. So if I were to look into Hawaii, for example, we could see at this point in time, which is roughly 1980, Hawaii's unemployment rate was 4.9%, which is 2.8% below the national average. And as you can see, as I move along here, that information in my tooltip is updated as expected in any other visualization type. The difference between this visualization type and another visualization type, simply like a line or a bar chart, is the fact that not only are we showing a large amount of information, but in addition, we're also stacking this information on top of each other so that the highest level is shown at the top. So what I mean by this is as I'm scrolling along in Hawaii, for example, you'll see here this first gradient of green. You'll see this difference from average will range from 0% to a negative 2%. And once I hit negative 2%, I'm going to start plotting this other color of green, the second color. This is my second band of my positive horizons. And as you'll see this continue along, I'm going to hit about 4% here because my band size right now is at 2%, which we'll cover later. And now I'm in this third green at the very bottom here. So effectively what I'm doing is I'm taking a time series, splitting it into multiple sections, and then stacking the sections on top of one another. This is how we can get at so much information so quickly in such a very compelling visual manner with these horizon charts. So for today, this is where we're going to focus our time, and let's go ahead and dive into it. So now that we have a brief introduction to what this visualization type is showing, we're going to go through the process of building it from the ground up. So I'm just going to start by opening my new sheet here. And for those of you that want, I do have this workbook attached to the video on the website, so you can feel free to download this and work through this step by step as I walk through it with you. So since we were looking at our unemployment by state, first thing we're going to need is to put our state onto rows. And I'm also going to drag with my right click my month out onto columns. And from this bottom list of continuous dates, I'm going to choose day. So now we can see that we've just got our days plotted by state for about the last 40 years, from about mid-70s to 2012. And now what we want to get at is our unemployment rate. So in this data set, you can see we have employment numbers, total labor force numbers, and unemployment numbers. So what we want to do is create a calculated field that's going to call out the portion of the labor force that's unemployed. So given that, I know I have to create a calculated field here. And we'll just call this our unemployment rate. And here I want my sum of my unemployment divided by the sum of my labor force. This is going to return the ratio of my labor force that's actually unemployed. So when we click OK here, I'm going to want to right click this and format this as a percentage because it's always going to be a ratio less than or equal to 1. Now that we have this unemployment rate, we can bring this out onto the field here and see what it looks like by state. So here's our unemployment rate. Now what we need to do is not only have our state's unemployment rates, but in addition we need to have the overall unemployment rate. This is crucial because the horizon chart isn't just plotting unemployment rates by state, it's plotting the difference from the average unemployment rate. And this can be achieved using a table calculation. So what I'm going to do is I'm going to create another field here. And we're just going to do a total of our unemployment rate. And we will call this our total unemployment rate. And what we're going to do here is I'm going to bring this out onto the view as well. And you'll see right now it's going to show up as a constant because it's just calculating it across the whole table. But what we want this to do is we want it to compute using state. And this is going to give us a new total unemployment rate for every point in time. And again, we're going to want to format this as a percentage. So now that we have these two different rates, what we really want to be able to do is compare the two to see how one state performs against the overall nationwide unemployment rate. So I'm just going to make this into a dual axis chart quickly here. And I'm going to right click and choose to synchronize these axes. This really starts to get at the goal of the horizon chart visualization type. So what we're going to look for is we need to find the difference between our unemployment rate, this orange line, and this blue line, our total unemployment rate. This is going to give us a state's performance relative to the national unemployment rate. So that is how we're getting those banding on the original horizon chart view. Those colors are denoted by different levels of differences from these two lines. So as we get a bigger gap, we're going to have darker colors. As we get closer together, we're going to have that yellow or the light green or the red. So what we need to do now is create another calculated field that just takes the difference of these two. So we'll just call this our difference from average. And this calculation is going to be as simple as it sounds. It's just going to be our unemployment rate minus our total unemployment rate. So we can just drag this out into the view as well. And since we know we had to set a specific compute using on total unemployment, it's always a good practice to make sure that that's inherited here by choosing state again, just to make sure that we don't have any problems caused by that. So this green line is effectively what we're going to try to plot. And if we want to see it very similar to the final visualization here, we can actually just change this mark type to an area chart. And so now what we're going to see is we'll see our raw lines here, our unemployment rate, the orange, and our total, the blue, and then the difference between each of those lines. Our end goal here is to be able to plot every single one of these area charts in a very compact table with the banding denoting the variance and difference from the average. So now that we have the basis of all of these calculations set, we're just going to call this our base value sheet. And what I want to do here is I want to right click this and duplicate my sheet. And then I'm going to change a couple of the fields displayed here so that we can get at the next step of this process. So I'm just going to move my unemployment rate and total unemployment rate to the level of detail here. It's basically going to leave me with simply this difference from average area chart. Because what I need to do now is I need to find out what are the ranges for my difference from average. And again, I should quickly format this by right-clicking and putting it to a percentage. So the goal here is to find out what range, both positive and negative, am I going to need to account for in this horizon chart. So I'm just going to label my min and max and choose table. What this is going to do is it's going to show me the minimum on the negative side and the maximum on the positive side that exists within my table. So if I just scroll down, I'll be able to find the appropriate ranges here. So it looks like my negative range is going to be about 6%. And on the positive side, we're going to account for 15, but given the rest of this view, that appears to be a pretty big outlier, so we can probably account for less on our band sizing. These two numbers, so the -6 and the +15, are very important numbers in this case because it's going to dictate how many different calculations are required to get the various banding levels. So we're just going to call this our min and max. And we're going to build out a new sheet here. I'll just duplicate this one again. Here now what I want to do is I just want to take this off and I'm going to start building out the calculations that are required to make this visualization type actually happen. So we're just going to change this back to automatic just so that we can see all the information here and remove our labels. What we need to do is we need to start building out the calculations. The calculations that are necessary here are the ones that are going to split that difference from average area chart into the various levels that we can then stack on top of one another to get the final visualization. So now that we understand where we are in the process, we're now really at the point at which we can start trying to build out those various bands that we saw on the first view of today's video. So I'm just going to right click here and choose Create Calculated Field, and we're going to call this our Horizon plus 1. All of these different calculations are just various levels of that band, so what we're going to start doing is building them out one by one. First, what we need to do is we need to create a parameter. We're going to call this our Horizon Band Size parameter, and we're going to want this to be a floating variable that basically allows us to have a range that includes our percentages, so our decimal points. So what I want to do is I want to allow people to choose between a 2% band, and this is going to be the band which we're going to build this off of, because when you're building this out, you need to take into account the smallest band possible so that you build out enough of the horizon level calculations. And we're going to allow a maximum of 0.1, and we'll make the step size 0.01. So now that we've got this parameter here, what we can do is we can start to build out this calculation. So first what we need to do is we need to build out our Horizon plus 1 here, and that's going to be anything between 0 and 2%. So we have to check difference from average and see if it's greater than or equal to 0. And this is crucial, and this is going to be repeated in every single one of these calculations. We need to check if the difference of average is less than or equal to our band size. Then, and we want our difference from average here, and we're going to divide it by our band size. Now this may not be obvious to what it's doing right now. It will be in the end. I'll discuss it briefly here. I chose the wrong parameter here. What our end goal is here, because of this band size, we want this solution not only to be beautiful, but we want it to be interactive. We want our users to be able to set the parameter levels. They want to set the band size. We don't want to force them into seeing it in one manner. Having this band size right here, so dividing our difference of average by band size, is going to allow us to have a fixed axis while retaining the interaction with the parameter. And you'll see what that looks like in the very end of the video when we finish building this out. So this is the first step, but we also need to account for within this horizon level for the case where the difference from average is greater than our band size. And what we're going to do here is we're going to just say then 1 and end it. And this is our first horizon level. This part right here is very important to understand. If you don't understand this, the most of the rest of the video is not going to make much sense. So if our difference from average is above 2%, this is our starting point for our band size. You can see the current value is 2%. If it's greater than that, we're going to return a 1. And that's related to this calculation here. So if this is, for example, 0.18%, this is going to be, very close to 1. But this 1 is basically setting that upper limit of the axis. So when we hit, say, for example, a 3% difference from average in the Horizon plus 1 level here, we're going to return a 1. So we're going to plot that first band all the way to the top of the axis, and then we're going to start to plot that second band from the bottom up to the middle of the axis. So this will make a lot more sense once we see the final version, but I wanted to make sure that we hash that out before we continue. So now that I've got my first horizon, and again we're working on that assumption that we're going to go up to about 8% because that 15% maximum looked like a pretty serious outlier. So we're going to go ahead and right click this and choose duplicate, because all these formulas are very similar. What we're going to do here is we're just going to edit this. And what I want to do here is now I want to make sure it's greater than or equal to my band size. And again, the wrong parameter here briefly. And less than or equal to 2 times my band size. This is because we're now looking at the 0.2, so 2% to 4%, so we'll call this our horizon plus 2. And now that we're adjusting this higher onto our bands here, we need to make sure that we account for this jump in this calculation here. So we need to actually subtract our horizon band size from this number so that this number will always, this resulting number here, will always be between 0 and 0.2. So that when we divide it by our horizon band size, again, our 0.2, we're going to be able to retain that axis fixed from 0 to 1 while still having that interaction for our users. In addition, we need to change this to 2 times the band size because now we're checking to see if our difference from average is over 4%. Then we're going to plot that all the way up, and then we'll have to use horizon plus 3 to plot the remainder. So we're going to leave that as horizon plus 2. And you'll see as I go through these are very, very similar. It's just a matter, once you get a couple, of just changing the formula slightly. So our horizon plus 3, what we're going to need to do here is we're just going to change this to 2 times, change this to 3, as well as this here. And you'll start to notice a pattern here. We're going to add this as 2 times and make sure that we're calculating this correctly. And that's going to be our horizon plus 3. And again, we're going to do a very similar thing for our horizon plus 4. So we're going to change these 2's to 3's, and these 3's here to 4. Yep, and I will rename that as well to horizon plus 4 so that we have no confusion. And now what we can do is we can start on making the horizon minus 1's. So in order to make the horizons for the negative side of things, we're going to again start by duplicating our horizon plus 1 field, and we're just going to edit this. And we'll call this horizon minus 1, and this is going to be very similar to what we did previously with the positive horizons. It's just going to be a matter of changing the equality signs around. So instead of greater than or equal to 0, we're just going to have less than, because we've accounted for the case in which it's 0 with our horizon plus 1 calculation, as you can see here. And in addition, we are going to have to change this from less than or equal to horizon band size to greater than or equal to a minus horizon band size. This part of the calculation is going to have to change as well because this is going to return a negative value as we're looking at values below 0. So what we want to do is take the absolute value of this and then divide it by our horizon band size. Again, we have to swap this final equality sign, and then this calculation is complete. Basically what this is doing, in case I didn't explain it clearly enough earlier, is this is going to swap not only the sign of this, but it's then going to continue to plot this between that 0 to 1 range, so we're going to be able to stack all of this information on top of each other. So let's go ahead and save that one. And now we're going to duplicate this again, and we're going to do a very similar process to what we did before with having our minus 2 band sizes here as the maximum. So I'll set our minimum here, so less than or equal, less than our negative horizon band size, and then minus 2 times. And then again, we're going to have to start subtracting our band size here at this level so that we can make sure that we're retaining, again, the same range for the axes. And we're going to make that a 2 here as well. And that is our horizon minus 2. As you can see, it is again the same exact process as we went through with the positives. Now I just have to change all of my 1's to 2's within this next calculation and all of my 2's to 3's. So we'll do minus 2 times our band size, 3 times here, and we'll add our 2 times band size there. And finally we'll change our bottom 2 to a 3. And since we know that that minus 6% was our lowest negative value, we're going to keep the 3 as our maximum number of horizon calculations. This is again very dependent on your data set and the range in which you have values for whatever field you're looking at in this visualization type. So that is purely determined on your side. This is just what I'm recommending for this sample data set so that you can continue to work through it with me. The next step here is to make sure that our information is being plotted correctly when we use all those different horizon calculations. So what we're going to do here is we're going to utilize Tableau's measure value measure on this visualization just to get all of those out there at the same time. I paused automatic updates there as we're going to have to do some work to clean this list up a bit. So I'm just going to add my difference from average to my level of detail here so that I've got that information on the visualization. And furthermore, I'm going to click on Horizon plus 1 and hold my Shift key and select all my horizon calculations. Right click and set the compute using to state, just so we've got that same setup as before. And now I'm just going to remove the rest of the measures from this list here. All we want to be left with here is our 7 horizon fields. And we also want to put measure names onto color, because measure names is going to color each line based on whether it's in horizon 1, 2, 3, 4, and so on. And we want to set this to line. Now if I unpause updates, what Tableau is going to do is it's going to start computing all this information. It's probably going to take about 20 seconds on my computer. And then what's going to happen is you're going to see for each state a starting look at our final visualization. You're going to see a number of different colored lines. Based on the legend that's going to appear, we can change the colors to match the view we started with during the video, just so we can start to get even closer to that final visualization of our horizon chart for unemployment. So as you can see, we have some work to do here. So the first thing I want to do is go ahead and hide this indicator. This is the nulls that are showing up here are for the cases in which the difference from average doesn't fall into a specific horizon. So if it doesn't match horizon plus 1, rather it's a horizon minus 1, we get a null there for horizon plus 1. So we can just go ahead and hide that indicator. We don't need to do anything with that information. What we want to do here, however, and this is what I was talking about before with the calculations, why that 1 is very important. As you can see, in this case of California, when we hit a difference from average of about 2%, we get this line up top, and that's our 1. And then below that, this is our second level of that horizon where we start seeing differences between 2 and 4%. So that this is how we're stacking that. Now what we want to do is we want to make sure that we're coloring this in a way that makes sense. So when we have people that are above the horizon, so a positive 4, we want that to be a very dark red so that people can actually see the information in an appropriate way. It's not going to make much sense for that to be green because being above the average unemployment rate is not really a positive thing. So what we're going to go ahead and do here is we're just going to double click our legend here, and we're going to bring up the formatting dialog. And what this is going to allow me to do is it's going to allow me to assign the different colors. So I'm going to use the traffic light palette here, and I'm just going to assign my 1 a very light yellow, and then start going up in severity with my greens here because this is, my reds. Because these are the problem states. These are the states with really high unemployment above the average. And then here we're going to want to use our green so that the darkest green represents the states with which the lowest levels of unemployment are associated. So I'm going to go ahead and click OK, and this is just going to assign it to all of my lines here. The reason you can tell that this is going to take some time to compute whenever we make a change is the fact that we're plotting about 155,000 marks with this, because we've got a number of different days in the last 40 years, and we're plotting that for every single state. And so now we're getting what looks like to be the start of a horizon chart here. So you can see we've got all the lines. They seem to be colored appropriately. When we get a flat line here, there's a line below it that starts as a new curve. So we know that this is functioning so far. The final few things that we need to do here, we need to fix this axis. So I want to make this fixed from 0 to 1. And again, that's due to that divide by band size in every single calculation. No matter what my user does to change the information, this axis is going to work for every single adjustment. So I'm just going to go ahead and click OK here. And we don't actually need to see this header at all. So I'm just going to right click and uncheck show header. It's just going to hide that axis so we don't have to look at that over time. So what we want to do now quickly is we want to just change this into the visualization that we want to see. So right now we've got this as our line chart. That's great. But what we really want to see is we want to see that stacked area chart. So I'm just going to change this to an area type from my marks card. And this is again going to take a few moments to compute. And then once we get there, we're going to have that final area chart style where we've got the stacked information so that we can call out right away the states with good performing employment rates and the states like Alaska that tend to be above the national average insofar as unemployment rate. So again, it's going to take a few seconds to compute here. This is just Tableau cranking away on our different table calculations. And now we've got that visualization set up. So as you can see, because of the order in which we have our color legend, I'm able to scroll across this and highlight the most important categories. And I see my darker greens, I see my reds, and I'm able to go from the darker reds to the lighter reds when it's appropriate. So we can do some other things to format this, like decreasing the size here, throwing this onto a dashboard, or even things along the lines of, say for example with Puerto Rico, we don't want to see this state. It's clearly skewing the results because the average is including this information. We can just right click and exclude this state because it's clearly an outlier. So now this is going to adjust all of my other information based on that exclusion, and then we can really just add this to a dashboard after we do some work just to format the tooltip a little bit better. So really what we're doing right now is getting ready to finish the product. This is going to be our end result of our horizon chart. And from here you can start to see possible ways in which this would be useful in your own data environment at your own company. There are some specific requirements for the horizon charts. As you can see here, I do have a lot of information, and that is very useful because without a lot of information and persistent data for that matter, and what I mean by that is, unemployment rates change, but they don't change rapidly. So this time series has some persistence in it. So that's why we can get this consistent coloring over time, and then these consistent areas where a change occurs or a huge spike happens, and you can call that out. If there's too much variation, a horizon chart may not be the best solution in your case. So we'll just size this down a bit just to get a little bit more information shown at once. And then what I want to do is I want to go up here to Worksheet and work on the tooltip a bit. So obviously we don't need all this information in here. I'm just going to start deleting some stuff so we can get out some crucial information. So really all we need to see is my state, the unemployment rate, and the difference from average. So we're just going to make sure the unemployment rate shows up first. And instead of bolding this one, we'll just underline it. So now when I hover over any mark, I'm going to see right away really the two bits of information that I'm actually interested in, the two bits that are supposed to be shown by this horizon chart. So let's call this our final horizon chart. And now the final thing I want to go through is our parameter. And this is why I allowed the calculations to change and I forced the band size to make our axes from 0 to 1. Because now if I change this to 0.5, my bands are going to update. The view is going to have to recalculate, obviously. But because of this change, I'm not going to have to go back and re-edit the axes. The axes 0 to 1 is going to function no matter what band size my user chooses because of the way that we built that calculation. And this is really where the power of Tableau comes into this chart type. Not only are we taking all of the work out of this, since the calculations required for this are pretty standard if-then logic, but now we're even allowing interactivity with this really powerful chart type. So if there's a specific level at which your users want to see this information, they can make that selection at their will. So this is really where I want to end this video. I want to thank everyone for their time. I really hope you get a lot of information out of this video. I know I learned a lot just making it. While we're finishing off this visualization here, I do want to thank one of our customers actually. Joe Mako is responsible for really inspiring this video. He originally made an example using this data set a couple of months ago and put it on Tableau Public, and this is really where I got the inspiration and the data for that matter to build out this video. So again, I want to thank him for his work. But the reason we love working here at Tableau is customers like you are constantly teaching us as well. And it's really great having that back and forth interaction. So if you see Joe Mako at the conference, give him a thumbs up for inspiring the Horizon Chart video. Again, I want to thank everyone for your time and happy analyzing.